Hello everyone, welcome to Elite Engineer. In this video, this is actually a special video for maximum PowerPoint tracking technique. You would have seen the various basic maximum PowerPoint tracking techniques in the previous videos, like perturb and observe, incremental conductance, with buck converter used here in place of zeta, buck, boost, zeta and sepic. Whereas I've already shown you the incremental conductance also for buck, boost, sepic and zeta. Now in this video, I would show you one of the special maximum PowerPoint tracking technique which is developed by me, and you would see that it will be lesser tracking time and lesser steady state oscillations. And the proof of that has been already published in IEEE paper, which is given in the comments below. And there is also a link given below which will be redirect you to the website where you can download this MATLAB simulation. So let's begin. So basically, I have taken here one solar PV panel which is connected with the signal block, where I'm changing my solar irradiations. Like I already told you that here up to 0.5 I'm considering that it's 800 watts like irradiation that is falling. So maximum 1000 watts it can fall, and then again it is 900 after at around 1.5. So this is a condition which I have taken, and you can change this accordingly if you just get the simulation file. And temperature I have considered 25 degrees Celsius, and when I click the solar PV panel, I'll get the configuration as 250 watts, 250.318. That this is a Canadian solar PV panel which I've considered, which is a user defined panel, which is already defined panel. If you want user defined panel, just click here, select the user defined, and just select the rating according to your configuration. Now there is something called, when you consider the 250 watts, it's not exactly the 250, right? This is something like you'll get the open circuit voltage, something short circuit voltage, voltage at maximum power point, and the current at maximum power point. Automatically this will take into consideration, right? If you want to just visualize this, just click in the plot and it will give you at 45 degree and 25 degree how my plot will look like. So at 25 degree I'll get the maximum power, which is 250.318, right? At 45 degree how much I'll get. You can change here this accordingly if you want to visualize here with one module 25 degrees Celsius and specified irradiation, and then you can click here and check the by changing irradiation how much power you are getting. So you can analyze by changing this display IV PV characteristics, right? So I'll just cancel it. Now what happened here is I already fed the input to the solar panel. Accordingly it will generate me output. Now it's my responsibility to check whichever converter I want. Like I'm actually in love with the zeta converter and the sepic converter due to some configuration of that. So I've considered here my zeta converter. In that the problem here is it considers an extra switching element, not switching element, it's extra elements like inductor and capacitor, which is not there in case of buck boost and buck boost converter, whereas it's present in the sepic and zeta converter. Now the input capacitor and output capacitor is already there, whereas the two specific elements, like if you consider one inductor and capacitor, there is an extra elements that is considered into zeta converter. Now this zeta converter calculation of inductor and capacitor has already been calculated from my reference source, the reference books which are already given in the literature. So based upon what output I want, based upon what input I have, this converter configuration of parameters of elements I have just calculated, right? Now here I've used one resistive source which is 35 ohms, and here it will give me output, right? So this is a very basic building block. Now what happened here is I've taken input from here, which is my VPVV, IPVV, and here this is the output, that is V0, I0. So VPVV, IPVV I am measuring here, V0, I0 I am measuring here. Now the V0, I0, the output, basically in the previous video I've shown you that I am using maximum PowerPoint tracking based upon my input of the converter. In this case I have considered my output of converter, and I have used that for my zeta converter, that is my K factor based maximum PowerPoint tracking technique. Now this is a zero order hold which is required, and then it will generate me the pulses, right? Now basically this is working on the closed loop fashion. What I'm doing here is I'm considering the output voltage from here, the output voltage, and the similar logic, the logic I have created here to generate the input voltage and input current. That is very simple logic. Now that is actually used here to visualize what is my input voltage and input current, right? Now this is a VPV IPV of the output of solar PV panel or input of zeta converter. This is very simple block. Let me run the simulation and show you how it is working. Yeah, I'll just show you what is actually advantage of using the K factor based maximum power point tracking technique, right? Yeah, it is actually running. It will let's wait for some time so that it should run properly. During the initialization process of the simulation, I'll just show you like how my K factor is affecting the simulation waveform. So why I have made this new maximum power point tracking technique when we already have much more advanced version of maximum power point tracking technique, right? So first of all, my irradiation is less, so it will track in this fashion. See, in this fashion. So if we just zoom out this, you can clearly see that the step is continuously decreasing. Why? What is the reason for that? Actually, what happens is when my simulation will run, it starts from the right hand side and it tries to oscillate when it reaches the maximum power point. So we are considering the range for oscillation very huge. So it will oscillate very huge value. But when I consider from here, when it starts from the right hand side, it oscillates at higher value and then it continuously decreases, and when it reaches to a maximum point, it reduces. See, it reduces here. It reduces, right? So what happened? Why I'm using here in this fashion? Because it will create lesser steady state oscillations in this case. See, when I talk about the oscillations, very less oscillations are coming, and the tracking time for reaching the maximum power point is also reduced by using this technique. So that's why I'm using this technique. If you want to get into much more deeper insights of this, I'll attach my paper which I published, so you can just see it and you'll come to know actually what is the advantage of using this. Okay, the K factor based maximum power point tracking technique. I'll just stop this simulation here. If you want more insight in this, you can just look into that paper, and if you have any doubts, you can just comment below. I'll answer all your queries. For simulation file, you just visit my website where you will be redirected to download this simulation file to get more deeper insights into this. So see you in the next video, and if you're not subscribed to our channel, please subscribe. Bye bye.